My name is Irene Meier. I work at Dr. Adam Brickman's lab at Columbia University, and our main focus is our cerebrovascular aspects of Alzheimer's disease. Alzheimer's is currently defined as plaques and tangles in the brain, and research has been showing that a lot of vascular factors are contributing to it. So we're looking at a bunch of markers that could help shed light on what's going on in the brain before we actually have clinical expression of Alzheimer's disease. My marker is our microbleeds, which are small hemorrhagic infarcts in the brain. They're thought to be a bridge between the amyloid from definition and the vascular factors playing into the disease and the progression of the disease. So what I do is basically we get like MRI images, the GRE sequence of the MRI, and they are small punctate lesions on this MRI scan. And there is no automatic process to quantify them, so I do this visually. I go through every single patient, slice by slice. I look at those, look for holes, and it depends a little bit on the strength of the magnet. The newer thing that we have now is a 7 Tesla magnet, which is a lot higher resolution, but it's also harder to detect those because you see a lot more little things going on in the brain, so they have a lot more false positives. So that's one of the projects that I'm currently working on. We have shown the subjects with microbleeds have a faster decline in cognition. That was on the lower strength magnet. And then on the 7T, we also found the same results, that microbleeds are associated with cognition. This is a cross-sectional study, but it's a nice finding, and it also shows that despite the higher, there's a high resolution, which is good, but despite the higher chance of false positives, you can still use, it's a useful tool to identify those microbleeds. A third study that we're currently doing is also longitudinal. We're looking at microbleeds and how they're associated with other small vessel cerebrovascular disease, like markers, like these white matter hyperintensities, which is my boss's topic. So we're basically showing also over time, so first of all, microbleeds are associated with white matter hyperintensities, with the burden of it. And what we're showing is that subjects with microbleeds, they increase faster, or they have a higher increase in the white matter hyperintensity burden than subjects that have no microbleeds. And we're trying to show that these vascular risk factors really matter, or these markers really matter, and maybe we should rethink the definition of Alzheimer's disease. And it's not just plaques and tangles. It could be, very early on, before we see any clinical symptoms, that these markers are developing that are really contributing, and we should maybe include that in the diagnosis or when we examine patients and people.